Hello everybody, welcome to NEET Physics by our video channel. In today's video, we are going to solve a multiple choice question from unit 17 of our NEET syllabus, that is dual nature of matter and radiation. That is the question, sir. The question is, photons with energy 5 electron volt are incident on a cathode C in a photoelectric cell. The maximum energy of emitted photoelectron is 2 electron volt. So photons having the energy 5 electron volt, and the maximum energy of emitted photoelectrons is 2 electron volt. Okay. When photons of energy 6 electron volt are incident on C, no photoelectrons will reach anode A if the stopping potential of A relative to C is this much. How much? Minus 1 volt, minus 3 volt, plus 3 volt, plus 4 volt. So this question has been asked in the NEET examination the year 2016. So let us define what is stopping potential. Symbol is Vs. Stopping potential Vs is the negative potential. It means what? Option 3 and 4 are ruled out. The answer is only between 1 and 2. Okay. So it's a negative potential given to anode A. Used to stop photoelectrons from reaching the anode. It has been given here, when photons have energy, no photoelectrons will reach the anode. So now, the energy given by Vs, that is stopping potential, is equal to EVs must be equal to kinetic energy of photoelectrons. Okay, photoelectrons are coming out of the metal surface and they are moving with a particular velocity V. Then we will have a kinetic energy of half of this. It is kinetic energy. And you are giving a negative potential at the anode so that the kinetic energy is nullified and the electrons will not be able to reach anode. Okay. So Ke max is equal to EVs. It is equal to that. It is equal to half in v square, whatever it may be. So these are all the same terms. So this is equation. Now in our question, it has been by photoelectric equation, you know that H nu is equal to phi plus kinetic energy, E max. So it means you keep a phi on one side and bring Ke to the other side. So phi is equal to H nu minus Ke max. That will be equation. What is phi, sir? Photoelectric potential of the metal surface. By photoelectric equation, H nu is equal to phi plus Ke, kinetic energy. In case 1, maximum energy of emitted photoelectrons, Ke max is equal to 2 electron. The energy of photon is 5 electron. So making use of these two infrared data, you can find the value phi. That is photoelectric potential. Phi is equal to H nu 5 electron volt. Ke max 2 electron volt. So 5 minus 2, that is 3 electron volt. This is the photoelectric potential of the metal surface. You can use this value for case 2. What is case 2? H nu, energy of the photon is 6 electron volt. Initially, the photons of 5 eV was incident on the metal surface. In the second case, 6 eV. So Ke max is equal to, that is EVs is equal to H nu minus 5. What minus 5, sir? So you put Ke max to the other side and 5 to this side, you will get H nu minus 5. It is equal to Ke, isn't it? So Ke max is equal to EVs is equal to H nu minus 5. I don't know, like, you just rearrange this equation. Bring Ke to this side and 5 to that side. Ke max is equal to H nu minus 5. Okay, H nu minus 5. So it is EVs is equal to, what is in the second case, H nu is equal to 6 electron. 5, you already found that it is 3 electron. 6 minus 3, that is equal to 3 electron. E into Vs is equal to 3 eV. So Vs is equal to 3V. E emitted the charge. So Vs is equal to 3V. But it is not really 3V. Already I told you that V must always be negative. Stopping potential is always a negative potential. So Vs is equal to minus 3 volt. You must add the negative sign there. So option 2 is the right answer for this question. Okay. We will see one more question from this unit 17 uh, that is a dual nature of matter and radiation. I'd rather to say radiation and matter. Okay, that's all. In our next video also. Till then, thank you and thank you.